So there's no doubt that the Roman ruins are beautiful, and also very old. But interestingly, scientists have just found out something about the concrete in these structures that could change the way we build stuff right now, possibly reducing our emissions by hundreds of millions of tons every year. You see, the Roman ruins were made quite a long time ago, and are still standing. That might seem like a silly statement, but modern concrete gets potholes and cracks and needs to be resealed with more concrete every few decades, or the entire thing will just crumble to dust. So why, after 2,700 years, are the Roman ruins not full of potholes or crumble to dust? And how can that help solve climate change? In order to understand this, we need to know a few things about the production of concrete. Modern concrete is made up of something called Portland cement, and a structure made up of the stuff can last about 50 to 100 years. It's made up of a mix of clay, limestone, silica sand, and a bunch of other stuff. This stuff is then fired at 2,000 degrees Celsius and then crushed into dust. This dust is then mixed with some chunks of stone or sand and finally water to make, ta-da, the concrete we know and love. I'm simplifying it, but you get the idea. Now, Roman concrete is slightly different, using limestone and volcanic dust crushed and then cooked, then mixed with ocean water to create lovely concrete to make a lovely fight to the death arena. Okay, so we originally thought maybe the salt water was reacting with the concrete to make it stronger, but actually it's this volcanic dust, which makes the concrete self-healing. See, today we aim for the materials in concrete to be non-reactive, so when you seal it up, there's no weird chemical reactions later on. As you could have guessed, the Roman concrete does the complete opposite, creating chemical reactions centuries later, and this allows it to reseal and stop cracks from expanding further. This could be huge for the way we make concrete today, as modern roads at the moment have a bit of a problem, like they don't last that long. Every 25 years they get potholes and cracks and we need to pour more concrete all over them. This would be fine, except the production of concrete is extremely taxing on the environment. Concrete production accounts for 8% of global greenhouse emissions, which might not sound like a lot, but it's producing 2 billion tons of CO2 every year. That's more CO2 than the 30 million commercial flights flown in 2023 produced. So you can imagine reducing the amount of times we need to reseal a road from every 25 years to every 1,000 could significantly reduce the amount of climate change concrete production has on the environment. So, great, let's just switch, but it's of course not that easy. Finding the right types of volcanic rock for mass-produced scale would be incredibly difficult, if not unviable. And a change in concrete manufacturing like this would take time and investment, as well as changing regulations and testing. And if we did manage it, it wouldn't solve climate change, not even close. But it would be a step in the right direction. So funnily enough, after 2,000 years, we are only just starting to crack the surface of what makes the concrete that makes up these amazing structures so durable. And I find it interesting how something so far in the past could change things in the future. Speaking of the future, if you want to find out why flying cars are not going to be joining us there, click this video. Also subscribe, because we're halfway to 1,000 and it would be really awesome